Welcome to the project demonstration of micro inverter design for microgrid. So here this grid application is can be done through this solar power. So we are using the PV microgrid here. So from the solar panel the voltage will be given as input to the battery pack through this buck converter, which is acting as a MPPT for maximum power point tracking purpose. The output of this MPPT is input to the battery pack. So from here, we can charge a battery pack either from the grid, so from 230 volts, and this is the renewable source of solar panel. So as we can see the low light intensity, we are getting the low intensity from this charging light indication. So here this MPPT circuit consists of a buck converter. Nothing but this MOSFET will acting as a buck converter here, and that will be achieved by this microcontroller. So the purpose of this buck converter for MPPT operation is when we are utilizing a 12 volt solar panel to charge a 12 volts battery pack. So if the voltage from the solar panel is increased more than 14.5, then the remaining voltage should be buck means regulated with the help of this MPPT circuit of buck converter. So here I am talking about the 12 volt solar panel, but why the voltage is increased above 14.5 means, though we are using the 12 volt solar panel, the ratings of the solar panel is, we can observe that, so maximum power is 5 watts and maximum voltage is 17.54, and next open circuit voltage is 21.4 as the current is 0.29. So here we can see that the maximum voltage is getting from this is 21.4 volt, though we are using the 12 volt solar panel. So when we place this under full sunlight, this 12 volt solar panel will provide 21 volts, and as we discussed, the wattage is 5 watts. In order to make the V into I equal to 5 watts, whenever the voltage is increases, the current will decreases, as it can't provide the more than 5 watts, though voltages can be increased up to 21 volts from 12 volts, but the wattage of the solar panel is always remains same, that is a 5 watt only. So that in order to maintain the 5 watts, the so called current will decreases, so that we are not getting the maximum current, maximum voltage. That is called as a maximum power point tracking. So that will be achieved by our microcontroller with the help of this buck converter whenever the voltage is crosses 14.5. Why 14.5 means, when we want to charge a 12 volts battery pack, we need to provide the 14.5 volts, 14 to 14.5. That is the charging voltage of 12 volt battery pack. So that's why our threshold value is 14.5 volts. So that will be continuously done by our PIC microcontroller. Along with, for grid application purpose, we are using the HB circuits. So the main power flow in our project is solar panel to the MPPT circuits, that is called the buck converter, from there to the charging circuits, and from there to this battery pack, and from the battery pack is a 12 volts DC 2 amps of current we are using, that is input to the H bridge as well as to the microcontroller. So the microcontroller will convert the 12 volts DC to 12 volts of AC with the help of this HB circuit, as it has the 4 MOSFETs, that is called full bridge inverting circuits. So that is done by our microcontroller, and it will continuously generating the 50 hertz of frequency signals to this HB circuit, so which is used to convert the 12 volts DC to 12 volts of AC. The 12 volts of AC input to the step up transformer, so which is used to convert this 12 step up the 12 volts AC to 230 volts AC. So that is output to the grid section directly. So this is the microgrid application with help of our microcontroller, along with the solar power is a modification to that, means is a addition to our project. So your stages is power generation, and to the storage, and from there to the inverter, and from there to the step up, and to the grid application directly. So this is the main power flow. So here, so this is not a part of the project, the transformer. So we are using transformer just to charging a battery pack whenever the sunlight is not available. For that purpose, just disconnect this and connect the transformer, and on the 230 volts power supply to this transformer. There you can see the light intensity is more, as of now the battery is charging with the help of the grid directly to 230 volts AC inputs. So whenever the battery will take the time of around 5 to 6 hours to be fully charged. So if you can see, the battery pack consists of 6 batteries. So in that, each battery of 4 volt 1 amp, in that these 3 are in series 12 volt 1 amp, and these 3 are in series 12 volt 1 amp. These two sections are connected in parallel, so we'll get 12 volts 2 amp of DC output directly. And the charging time, as we discussed, either from the solar panel Generally without MPPT, if you place a solar panel, then it will take 8 hours to be fully charged for this battery pack. So when you are using the MPPT circuit, the buck converter, it will take around 3 to 4 hours maximum to get fully charged. Either from the transformer also, it will get full charge in duration of 4 hours. So till the duration, we should keep the battery under charging before demonstration of the project, either from the solar panel or a transformer. Just connecting this here. And when we place this solar panel under the sunlight, automatically the microcontroller continuously set the buck converter levels to the 14.5 volts maximum, and that is input to the charging circuits, and from there to the battery pack. And when we on the kit, there you can see the switch. So when we on the kit, so after light on and off 2 times, it's continuously providing the pulse signals parallelly to this buck converter as well as to the H bridge. So H bridge is 50 Hz pulses, and to this one 30% of duty cycle is given to this MOSFET to provide the 14.5 volts maximum. So here the stages as we discussed. So here the 2 stages inverter in the grid section. One is the inverter to convert 12 volts DC to AC, and a step up to the grid directly. So this is the power flow and features. So the main application of these projects is in the industrial. Directly we can utilize this solar power for the grid applications. The grid applications nothing but we can utilize the 230 volts loads by using this project. Thank you.